Yeah, so I've gotten a bunch done since my last video. Welcome back. This is the Vulkan project I've been working on. I got hooked up to a physics engine, woo, and I have actual player input and stuff. Woo, look, I have movement. Um, yeah, I did not expect this step to happen so damn fast, but here it is. I was talking to I got physics hooked up literally last night, and then talking to a friend. They're like, "How long till you can like have an actual game running?" I'm like, "Oh, maybe a week." But I'm heading out of town this week, so a few weeks. It's the next day. Uh, so I got player movement. I can interact with boxes. Ooh, boxes can interact with each other. I can click, and it creates projectiles. And the projectiles, when they after a while they die. 10 seconds. Any day now. There you go. I want to make it clear I did not write the physics engine. Yeah, this is not my physics code. This is using the Rapier physics engine, which is it seems to be exceedingly fast and seems to be quite stable. And supports everything I need and is Rust native, so it's a win-win-win. It is a bit annoying in some spots, but so I've done a bunch of work. The fact that I have player movement, and I got air strafing, and like I've got interactivity, and just like all of this, right? Like this is a lot more than just like hard coded Vulkan code, right? So there's a bunch of stuff going on here that I'm not all of it I'm entirely happy about, but most of it I am pretty happy about. Boop, there it goes. So let's go take a look at what's powering this. So entirely new entity system. Entirely new entity system. The entity system I had before was mostly just like, hey, I can remove meshes from the scene. That was about it. This is a lot more. A lot more. The core of the system is, well, if I scroll down here, here's all the values in the entity system. It's a lot. We got some fun things going on here, like brain jars. Ooh, what are those? We're gonna talk about that. Fun terminology. I'm not entirely happy with how this is structured, because I would prefer the less indexing or pointer chasing you have to do, the better, always, because the CPU is better able to guess what you need to get ahead of time. There's less work to do, all sorts of things. It's never good to have tons and tons of lookups. This system has a lot more lookups than I want it to have. Some of them are forced upon me by the physics engine. Some of them are forced upon me by just the nature of how general I'm trying to build the system to be, which is not too general, but still fairly general. That I can just like build stuff on top. I have a specific game project in mind at this point, but I want to be able to build on this code base for all sorts of stuff. So the core of the system are these brain jars and some arenas which are kept in sync with each other implicitly. I'm not very happy with that, and they are the cause of most of the lookups. Again, these two things here and all this stuff down here is all required by the physics engine, so I kind of have to work by its rules when handling entity indexes. So ideally, when you have a bunch of entities, they all fit into some sort of category, and each category shares logic, right? Like you might have a bunch of projectiles, a bunch of balls, or a bunch of cubes, and all of your projectiles have the same logic, right? All your cannonballs have the same logic, right? And that logic may be different from a bullet, but all your bullets have the same logic, that sort of thing, right? So ideally, you want to have a big old list of all your cannonballs, and you want to be able to iterate through all of them and run the same logic on all of them, right? because that's a heck of a lot faster. Because for a lot more of the data you need to touch is able to be cached ahead of time, and both the compiler and the CPU know where you're jumping to, as opposed to if you have a big old list of various entities and then use virtual function calls to call their update functions, right? That's a lot more expensive. So that's what these brain jars are for. They got a brain, and then they got some other information. But the brain is defined by a macro. This is about 100 lines of macro here. This is used in a few places right now. So here's the simplest brain. Call this the veggie brain. It has no data, and it calls this function right here. Passes in some arguments to the function, and the function has no logic. So this defines a struct called veggie brain, which has all of these methods on it, and like we can insert and get data out of it, and then we can tick all of the entities in that brain. So all of those cubes have the veggie brain attached to them. The veggie brain, it's a vegetable. It doesn't do anything. Originally this was called static brain, but like the logic here is detached from whether or not the physics body is dynamic or not. So this is better. So it passes in an entity context, so it can do some interesting stuff. It passes in the physics body. It passes in the data for that specific instance, some input information, and then delta. So this function will be called for every single entity with the veggie brain. And the veggie brain is responsible for storing all of the data for each instance of that type. And this means that when we tick all, we can go through each instance and call the logic on each one. But because each brain knows what it's calling internally, that means we only have one virtual function call, because the brain is dying. We only have one virtual function call per, if I can find it here. We only have one virtual function call per brain type. And then at that point, now that we're in that brain, the brain knows where it's calling out to. It's going to call out to the same place for all of it. The optimizer inside there, the compiler knew ahead of time, like, oh yeah, I can optimize it. Like, no virtual function calls in there. And there's a bunch of busy work to keep the data inside the brain in, wait, if I can find it again. This data inside the brain synced up with the outside world. What that means is if we open up the projectile, so the projectile, we define a projectile brain with projectile data, and it calls projectile brain tick. So projectile data has a single field, life left. It's a 32-bit float, and this is the tick for the projectile brain. It takes the delta that it gets given, subtracts it from that entity's life left, and if it's less than 0, less than or equal to 0, it asks the context to remove that entity, and that's it. And so there's when we go through these are the balls that I was firing earlier. As the entity system says, okay, I'm going to go check all the balls now. So it goes and grabs the projectile brain and says, hey, go run all of your balls. Go run the tick on all of your entities. And it can just go through and run all of them all at once. And if we come over here back to the entity system and we scroll up here, you can see we can reuse different brains for different types of things. So we have the player entity here, which has a player brain and has an empty model. We have a veggie brain on the ground with the ground model. We have a veggie brain on the cube entity with a cube model. We have a projectile brain on the projectile entity with a ball model. And we have a veggie brain on a monkey with a monkey model. I don't have the monkey. I don't have poor Suzanne hooked up anymore, because I haven't gone through the effort of getting triangular meshes hooked up yet with Rapier. So the monkey got that cubic collision mesh. So yeah, because the brain calling into the brain is a virtual function. This by kind here, the brain has no outside type information about what actual brain is inside there. So that means we can index into this with a jar index and then an inner index. And this inner index is into an arena which contains all sorts of stuff. This is a Rapier type, because I was going to end up building something like this anyway. But because I need to keep multiple arenas in sync with each other, both in Rapier's code and in my code, so that indices match up, it just made sense to reuse their arena type. I mean, it's almost identical to what I would have built, probably just a little bit more error checking than I would have ended up building. So it's a win-win. So yeah, it's here's the player brain, player data, which has momentum, and then a bunch of other data, and then calls player brain tick, and then here's the player logic. That's it. That's all the player logic right there. If I can click, that's all the player logic. But what's cool is because we got this data, right? The brain contains data for each of its entities. We can implement some logic on the player on that data. So here I have a camera translation method on the player data, which does some math on itself. This one actually doesn't actually use anything from within the player's data, but this one does. But this is just so that this data right here is right next to this data. Because if I change the height of the player, I need to change the height of that. But out here in the when I set up the camera position, I'm able to ask the scene entities to get data of player data type as a specific handle, and I keep track of the entity handle for the player object. And then this get data is able to go in there and pretty cheaply index in to go get that data. And then I'm able to use a bit of runtime type checking to say, basically it will return either the data, if the handle is invalid, you get a none. If the handle is valid but the data underlying is not of the type you wanted, you get a none. Otherwise you get a sum with the data. And so this is not as cheap as I would want it to be. But ideally you just wouldn't be able to reach into entities at all. But you kind of have to, like, say you want to grab some data off the player, or you want to have one NPC track another NPC. You need to be able to reach into each other. So this provides a way so that you have some sort of entity logic, and you have some sort of data attached to each of those entities with that logic. And then you can just like implement random public methods on that, and then pretty much anywhere you can just say, hey, can you give me that? And then you can handle that robustly if either that object doesn't exist anymore, or if that handle you have points to an object of the wrong type. So that's pretty handy. Like I said, I don't like that. It's more expensive than I'd like it to be. But what's cool is, like, if we look at the projectile, right? The projectile is freaking cheap. The veggie brain is even cheaper, but like the projectile brain does very little amount of logic. It does not need, like, it just tracks life and then tells the entity system to kill it when it reaches no life. Like, that's it, right? But it doesn't have to pay for any of those other things, because so these other things that are required in some instances that are more expensive aren't being paid for, which is really cool. I'll run the program again. So yeah, for about the getting design ending up with a design for the entity system that I liked. Took about a week of thought and trying different things until like this weekend I managed to find something I was somewhat okay with. And then Sunday yesterday I spent most of the evening getting it hooked up with a physics engine, and then today huge burst of energy. I got all sorts of actual gameplay logic implemented, which is cool. So yeah, they'll explain that pretty poorly, but it's a pretty complicated system with a lot of moving parts. So, whee, look at that thing go. Yeah, it's gone. Cool. Anyway, that's all. Thanks for watching. Cheers.